Today we're going to talk about polygon sums as we begin Unit 6, which is mainly focused on quadrilaterals. But the first thing we're going to talk about are polygons, and we're going to be talking about the interior and exterior measures of the angles and the sums of those polygons. So I guess really our jumping off point would be, what is a polygon? And for instance then, a polygon must have, each vertex can only have two segments on them. And it must be a closed two-dimensional figure. That is a polygon, okay? That's called a convex polygon, all right? This would be a concave polygon, and the best way I can describe it is it caves in. If it has any little nook in it or notch, that's called concave. We typically don't mess with concave polygons. We're normally focused just on convex, okay? And their interior angles, which obviously are on the inside, and then the exterior angles, which are found by extending each side in one direction, like a pinwheel. The sum of these angles out here are also what we're going to talk about. And notice that the interior and the exterior on each one make a line, so they're supplementary. So, talking about polygons now, this is a convex polygon. You can see that it has 1, 2, 3, 4, 5 sides. This is a pentagon then. Penta means 5. And consecutive vertices would be A, B, C, D, E. But if we skip a vertex and we draw a segment there, that's called a diagonal. And then if we draw another one, BE is a diagonal. So BD and BE are two diagonals of our pentagon. But notice, by drawing the number of diagonals from one vertex, we end up with 3 triangles. 1, 2, 3. Well, that should clue us in then what the degree measurement is of a pentagon. Well, since you have 3 triangles, 3 times 180 is 540. That is true for all convex pentagons. And where does the 3 come from? Right here. Every time we do it, it's going to divide it into n minus 2 triangles. And a triangle is 180 degrees. So for instance now, let me see if I can draw a hexagon quick. 1, 2, 3, 4, 5, 6. Now let me draw in the diagonals there from one vertex. 1, 2, 3. That gives us 1, 2, 3, 4 triangles. Right? So n minus 2 in this case, 1, 2, 3, 4, 5, 6. 6 minus 2 is 4. 4 times 180 gives me the total degrees in a 6-sided figure, which hopefully we know is a hexagon. So here's the formula on this next slide, as you can follow along with your notes, that all interior angle measure sums are given by the formula n minus 2 times 180. Now it does have to be convex, okay? Can't have any cave-ins, because then it doesn't work. Now, we're going to go back and forth to this chart, but it's very important that we know, first of all, the names of our polygons. So let's start there. I think we all know that is the 3-sided polygon is a triangle. 1, 2, 3. A 4-sided figure is a quadrilateral, and that's really what we're going to focus on in this chapter. A 5-sided is a pentagon. Penta means 5. 6 is a hexagon. Hexa means 6. 7 is a heptagon. Hepta means 7. We all know what an 8 is. It's a stop sign. It's an octagon. This is where it gets weird. 9 is called a nonagon. 10 10 years is a decade, so that's a decagon. 11, we're going to add uno to it. 1 plus 10 is 20, so undecagon. And then, as you could guess, we're going to drop the S, and a 12 is a dodecagon. Now, anything beyond 12, we just call it an enneagon. So like a 13-sided is a 13gon. A 14-sided is a 14gon. So, and so on, okay? Now, we know from the formula that the sum of the interior angles is n minus 2 times 180. So that formula goes down here. Now, it's also helpful. You can use the formula every time, but it's really helpful if you can memorize it, the degrees. So like we know that a triangle sum is 180. A quadrilateral then is double that, 360. A pentagon is 540, and you can notice we're just adding 180 each time. So an octagon is 1080. Now, and you don't have to memorize this. It just helps. Okay, decagon's 1440. Ooh, and then I'm stuck. Let's see, I'm gonna have to get a calculator. 80, I think that's 1620. And then I think it's 1800 for a dodecagon. And that's just simply found by putting it in your calculator and taking n minus 2 times 180. Now, the sum of the exterior angles, that's also, we'll be looking at that. We'll come back to that chart here in a bit. So now let's find the interior angle measures of this figure. First of all, you want to count the sides first, and I think there's 8. So if we're 8, it's an octagon. So I'm just going to use the formula n minus 2 times 180, which is 6 times 180. So that would be, let's see, 6 times 180 is 1080. My calculator's on its last leg. I have to get this thing plugged in here. Okay, the coin shown in the shape of an 11gon. Find the sum of the measures of the interior angles. Well, again, 11 is an undecagon. I don't know why they don't just say that, but they don't, and that's no big deal. So all we're going to do is plug it in the formula. So it's going to be 11 minus 2. Make sure you subtract 2 before you go into using the formula. So 11 minus 2 times 180 is 9 times 180, and that is 1620 degrees. Okay, so that's how we find the sum of the interior angles of a polygon. So digest that a little bit. And now let's talk about example 3, classifying a polygon by the number of sides. Okay. So if we know that the interior angles of a convex polygon is 900 degrees, then we could say that 900 equals n minus 2 times 180, right? If we're trying to find the number of sides, which is n. Well, now we just work backwards algebraically. And this is, again, why it's a good idea to memorize, because some of you that looking at your chart right now see that 900 degrees has, you know, how many sides, right? Well, we're going to undo times first, just because that is much easier. And that becomes 5. So 5 equals n minus 2. We're going to add 2. You have 7 sides. Now it says classify the polygon by the number of sides. So that is what we call a heptagon. Okay, so look that over and see what you think. Okay, So let's move on to quadrilaterals, which we've already said is equal to 360. Now that's very important. That's why we put it in here as a corollary. It's something we need to memorize. We need to know how many degrees, just like in a triangle's 180, then we can know that a quadrilateral is 360. So if we're going to find x, how would we do that? Well, I hope you're thinking, well, there's 360 total, and if I add these all up, I should get 360. So all I got to do is find x. So that's 288 plus x equals 360. I think that's 288, 180, yep. So now I'm going to subtract 288 to get x. And there's x, 72 degrees would be my x here. Okay? So that 360 really allows us to find those angles. So let's continue here. The sum of the measures of the interior angles of a convex polygon is 1440. Classify the polygon by the number of sides. So again, we're going to use the formula and set it equal to 1440. Now, if you remember my trick, the first thing you want to do is divide by 180. That is definitely the first thing you want to do. So 1440 divided by 180 is 8. So n minus 2 equals 8. We're going to add 2 to both sides. 10 sides. What's a 10-sided polygon? If you said decagon, you are correct. The other one says, what if these are our interior angles? Now it says it's a quadrilateral. How much will they add up to? 360, right. So all we're going to do is write them and set them, and add them, and set them equal to 360. So I think that becomes 16x. 1 plus 3 is 4, plus 5 is 9, plus 7 is 16. Divide by 16. 360 divided by 16 is 22.5. Now, what are all the interior angles? Well, we know one is 22.5. Another is 3 times 22.5, which is 67.5. We know another one is 5 times 22.5. One 12.5, and we know the third one is 7 times 22.5, 157.5. And there's our interior angles of our quadrilateral. Just have to use some algebra there. Now, here are some terms that we've already talked about earlier this year in first semester. And as we go through second semester here, especially in this chapter, we need to know this. An equilateral polygon means all the sides are congruent. An equiangular means all the angles are congruent. And if it's regular, it means they're both equilateral and equiangular. Now, we have talked about this before, but it helps us find angles. So here's a home plate, okay? Is that polygon regular? Hopefully you're saying no, because as you can see, we have 3 right angles, but angle E and angle C are not right angles. So this is a no, because not all the angles are equal. And it doesn't look like the sides are either, obviously. Now we're supposed to find the measures of angles C and E. Well, how are we going to do that? Well, how many degrees are in a pentagon? Well, we can take n minus 2 times 180. 3 times 180 is 540. We also know that A, B, and D are 90. So 90 times 3 plus, but we don't know what E and C are, so we'll say X. So we'll say plus X plus X. We know they're the same though, because it says they are. So 540 equals 270 plus 2X, because there's 2 X's. Let's see, so we got to subtract 270. Well, that's 270 equals 2x. Divide by 2. So x is 135 degrees. So angles C and E are both 135. But we wouldn't have known that if we don't know the sum of the angles is 540. Okay, now we're going to reverse directions just a little bit and talk about the exterior angles. Now those are found by taking a segment of our side and extending it in one direction and then doing it to all the sides in the same direction. So this is what, clockwise? We just extend them all clockwise in this picture. So it's like a pinwheel, okay? And it just so happens that if we have 5 interior, we have 5 exterior. Now here's what's cool. They all equal 360. No matter what shape you have, the sum is still 360. And I want to show you something here. I'm going to draw a triangle. Okay, that's terrible. Let's try this again. There's a triangle. Okay, this angle plus this angle plus this angle equals 360. Okay, now I'm going to draw a quadrilateral. So this angle plus this angle plus this angle plus this angle equals 360. Now a pentagon. This angle plus this angle plus this angle plus this angle plus this angle equals 360. Okay, hexagon. Now what I'm hoping you see is something happening to the interior angles and then something happening to the exterior angles, because that will explain this a little bit. Can you see that the interior angles start small but then get big as you move through the quadrilaterals, or the polygons, I mean? And as those interior angles get bigger, the exteriors get smaller. And if you can see what's happening here, the more sides we add, the more the polygon looks like a circle. And thus, that's why the exterior angles equal 360. So we can go back to our chart now and just fill this in. The sum of the exterior are all 360, always. It doesn't matter what shape. It's always 360, the sum of the exterior. All right, so knowing that, how do we find x in this picture? Well, we know that 2x plus 89 plus 67 plus x will equal how much? Right, 360, because they're exterior. Combining like terms gives me 3x, and 89 plus 67 is 156. So then I'm going to subtract 156. So 3x equals 204 divided by 3 equals 68. So this angle is 68, and 2 times 68 is 136. So that angle is 136. So the sum of the exterior angles allow us to find those two angles. Okay? Now, finding an angle measures in regular polygons. Okay, regular means what? All sides and all angles are the same. So the trampoline shown is shaped like a regular dodecagon. How many sides? How many angles? 12. So find the measure of one interior angle, not the sum, one. Okay, so let's see. I know that the sum is n minus 2 times 180, which is 12 minus 2 times 180, which is 1800. 10 times 180. I also know that there are 12 angles, right? So I can just divide that by 12 and get 150 degrees. So one interior angle is 150. What will each exterior angle be? Well, you could go 360 divided by 12, right? 30 degrees, because you have a sum of 360 and you have 12 equal exterior angles. But there's another way of thinking of it. What does an interior and an exterior make? They make a line. So if this right here is 150, then this right there has to be 30, because 150 plus 30 is 180. So there's lots of ways to do this. Now, if we have a convex hexagon with exterior angles measures 34, 49, 58, 67, and 75, what's the measure of the exterior angle at the sixth vertex? Remember, hexagon means 6. Well, I don't know, but I know they all add up to 360 because they're exterior. So all we have, oh, that should be a plus. All we have to do is add those together and then subtract them from 360, right? So 34 plus 49 plus 58 plus 67 plus 75 equals 283. So x plus 283 equals 360. Now I'm going to subtract 283, and I got 77 degrees. So that's the measure of the exterior angle on the sixth vertex. Okay, now on 2 it says an interior angle and an adjacent exterior angle form a line. How can you use this fact as another method to find the measure of each exterior angle in the problem above? Okay, let's see. How would we do that? How would we figure out that find the measure of each exterior? Well, I don't know that I'd want to do, I don't think we'd want to use the interiors, but you could. A hexagon's interiors would be 6 minus 2 times 180, which is 720. We could subtract then 180 minus that, 180 minus that, and so on. Boy, it'd be a lot of work, but we could still arrive at that number. I don't think I would do that, but you could. All right, the main thing here to remember is that the interior plus the exterior's got to equal 180. It's got to equal a line. So look at Canvas.